having understood about the effects of force, now let us do an activity now, children. Okay. So, here we have got a boy who is standing in front of the table. Notice what he does. He is pushing the book, and what happened to the book? It came to a stop. Who stopped this book? Did this boy stop it? No. Then who stopped it? Let us take another situation. Okay. We have got Raju here. Now, Raju is going to kick the ball. Just observe what happens once he kicks the ball. The ball has come to a stop. Who stopped this ball? Did this boy standing here stop the ball? No. But then, how did these two objects come to a stop? Or in general, how do moving objects come to a stop? Who made these objects to come to a stop? Okay. We do not see anyone stopping the objects. Fine. To understand all these things, we will do an activity, children. Are you all ready? Good. Now, all of you can stretch your hand as shown here. Just stretch your hand. Fine. And you all must be having some books with you. Place a few books on your hand. Have you all done that? Okay. Now, what do you feel on your hand? You feel the weight of the book on your hand. Isn't it, children? Yes. That means you feel that your palm is being pushed down. Don't you all feel it? If it is pushed down, then what does that mean? Yes, it means that there is a force acting on your hand. So, the weight of the book is exerting a force on your hand, and what will be the direction of this force, children? Yes, it will be in the downward direction. Okay. The weight of an object always acts in the downward direction, and this is the force that is acting. And this force will always be perpendicular to the ground, children. This force will always be perpendicular to the ground. Okay. And this force is denoted by the letter W. Now, you have to hold this hand at a particular position. Your hand should not go down due to the weight of the book. Then what should you do so that your hand remains in a particular position, children? Yes, you will be exerting a force on the book. What will be the direction of this force? Yes, it is in the upward direction. So, this force exerted by your hand on the book, we call it as the normal force, so that your hand stays in a particular position. And this normal force will always be perpendicular to the surface from where it acts. Here the surface is your palm, and this force will be perpendicular to your palm. Okay. It is perpendicular to the surface from where it acts. Is that clear, children? Okay. Fine. Suppose I have got a vertical pack and a block there. We all know if we place the block in this particular position, what is the direction of weight and what is the direction of normal. Suppose I want to place this block at some position here. Okay. I want to hold it so that it is at rest. What should I do? Yes, we need to apply a force on the block, and this block in turn applies a force on the plank. So, what is the direction of this applied force? Yes, against the plank. In this case, it is from right to left. So, in order to keep this block at rest, the plank in turn must exert a force on the block. And what will be the direction of this force, the normal force? Yes, towards the right, and it will be perpendicular to the plank. Okay. So, this force is a normal reaction force and it will be perpendicular to the plank. Okay. Have you all understood, children? The direction of normal force will be opposite to the applied force and it will be perpendicular to the surface from where it acts. Okay. So, if you have understood this, I want to know whether you have really understood. So, we have got this question time now. All of you can now open your clickers. Take out your clickers now. And here we have got a question. The question is, the normal force acting on the object placed on an inclined surface is indicated by ray OA, OB, OC or OD. You can see the diagram there, children. You will have to identify the normal ray out of all this. And your time starts now. I give you 30 seconds of time, children. Okay. I give you 30 seconds of time. Use your clickers and click on the correct option. Yes, I can see many clickers being on. There are a few more children who have to answer. 15 seconds over. The rest of the children? Yes, the time's up and the correct answer is option B is the correct answer. That is the ray OB. I can see that many of you have not got it. So, I will teach you again. Before that, let us see the winner house, children. Can you all see the winner house from your class? Yes, claps for that winner house. The other houses, in the other question, you must be able to get the winner. Okay, fine. Now, let us proceed further and I will teach those children who have not answered it correctly. Please pay attention. Now, when a book is at rest on the table is horizontal. What are the directions of weight and the normal force? Weight is acting downwards, normal force is acting upwards and it is perpendicular to the horizontal now. Okay. Now, if we have a vertical plank and we have an object placed there, then we have an applied force F acting on the plank. This is the force here and we have got the normal which is again perpendicular to the plank. This we know. And our question was, what happens if we have a inclined plane and we have got an object there? Okay. So, here we had given you 4 rays. This is the weight OA, OB, OC and OD. Out of this, which is the one that is perpendicular to the surface, that is to the inclined plane? We know OA, OC and OD are not perpendicular. So, the correct option is OB. Okay, children. So, you remember that the normal will always be perpendicular to the surface from where it acts. Okay. I hope now you all have understood. So, I have got again a question time for you now. Okay. Please take out your clickers and be ready for the question. And here goes the question. The normal is a force that acts in a direction, option A, opposite to the direction in which the weight of the object acts. Option B, perpendicular to the direction in which the weight of the object acts. Option C, perpendicular to the surface from where it acts. And option D, in any direction such as to balance the weight of the object. Your time starts now and I give you 30 seconds of time, children. Please choose the correct answer and click on the right button. Yes, I can see many clickers going up, a few more to go still. Good, good, good going. That's the spirit, children. That's the spirit. Yes, many are going. Wow, and the time's up. 3, 2, 1. Can I see the result now? Yes, many of you have answered. Claps to all. And let us see who is the winner from your, which house is the winner from your school, from your class. Wow, can you all see the winner from your class, children? I think in some schools it is the same and in some it is different. That's good. Now let us proceed further, children. Good going. Yes. In order to understand what made those objects come to a stop, we have understood about two forces, weight and normal. Now let us proceed further. Okay, you have got your book on your hand now again. Yes. Now slowly push the book and experience what you feel, children. Just experience. Push it. What do you feel? What do you experience? You feel that the book is pushing on your hand. Just slowly move it and feel it, children. You feel that the book is pushing on your hand. Okay? And in turn, what is your hand doing? What is your hand doing in turn? Yes, the hand is also pushing on your book. So, when any object is moving, we know that the force is exerted by one object on the other. Okay. So, this is one thing that you should remember. Okay. Now, we have got a book on the table and we all know what are the forces acting on this book when it is at rest. Which are the forces, children? The weight acting downwards and the normal reaction force acting upwards. Okay. So, does the effect of these two forces make the book move vertically? Is the book moving vertically? No, it is not moving. So, what can we conclude from this? What do we conclude? These two forces must be equal. That is, W must be equal to N. Okay, W equals N. Fine. Now, let us push the book. When the book is pushed, what are the forces acting on it? Let us analyze it, children. Okay. So, let us push the book again. As when you are pushing it, there is an applied force acting on the book. Okay. So, as soon as you finish pushing the book, does this force act anymore? No. This force just makes a book move. Once a book starts moving, this applied force does not act on the book. So, which are the forces acting on the book as the book moves? We know W and N are there, but these two forces does not help the book in the vertical motion. So, the force is exerted by the book on the table that we have seen through the activity, and in turn the table is also exerting another force on the book. Okay. But the force exerted by the book on the table has no effect on the table. The force exerted by the table on the book has got an effect, isn't it? This effect can be noticed. We know that W and N are not the forces that are acting. The only force that is acting is the force exerted by the table on the book. So, the force exerted by the table on the book is the only force acting on the book, since there is no vertical motion. So, the effect of this force is observed on the book. How do we observe the effect of this force? Yes, the speed of the book is reduced and it comes to a stop. So, we call this as the net force acting on the book. The net force is responsible for the book to come to a stop when it moves. Okay. So, this force has got a special name called as the frictional force, and this force is opposing the motion of the book. It is preventing the book from moving. So, this force exerted by the table on the book is the opposing force, and we give it a special name called as the frictional force. Since it is an opposing force or opposing the motion of the book, this force must act in a direction opposite to the direction in which the book is moving, or in general, the friction force acts in a direction opposite to the direction in which the object moves. Okay. Now, I have got a situation here. This is Riya. She is pushing the trolley. What is the direction in which the force is acting on the trolley? Yes, This is the direction of the applied force. And direction of movement of the trolley? Yes. So, direction of motion is from towards the left, isn't it? And what will be the direction of the opposing force? Yes, it must be towards the right. So, the opposing force is towards the right. So, you all must know that the opposing force acts in a direction opposite to the direction in which the object moves. Is it clear, children? Now, is it time for a question? Yes, it is the time for a question. And the question is, the force of friction acts in a direction dash the direction of motion of object. Options are same as, downwards to, perpendicular to and opposite to. Do you all have your clickers ready? Yes, and I give you 30 seconds of time, children. Okay, give you 30 seconds of time and all of you must be able to answer it properly now. Here goes the time. Yes, I can see many clickers going on. Yes, more and more clickers. Good going. A few more to go, I suppose. And the time is 15 seconds. Yeah, I am getting many correct answers as well. A few more have to answer it. Yes, time is up. And I can see that many of you have answered this rightly. And the correct answer is option D. Very good. And let's see which house is the winner from each class. Can you all see the winner from your class? Claps to those winners. Good going, children. Okay. So, we have understood all these concepts now. Let us move forward to understand more about this frictional force. Okay. Ready. So, we have seen what a frictional force is. Now, we go to understand something more about it. Okay, children.